Welcome to the Basic Fire Safety Awareness course, where you will learn the basics of dealing with fire, its preventions, and consequences. Fire, often regarded as a captivating yet formidable force of nature, is a complex chemical reaction characterized by the rapid oxidation of combustible materials in the presence of heat and oxygen. At its core, fire is a process of combustion wherein fuel undergoes a transformation, releasing energy in the form of heat and light. The ignition of a fire typically begins with the introduction of heat to a fuel source, initiating the chemical reaction known as combustion. This reaction generates thermal energy, which sustains the fire and facilitates its propagation. As the fire consumes available fuel, it produces flames, smoke, and other byproducts, further perpetuating the combustion process. Understanding the basic science behind fire is crucial for grasping its behavior and potential risks. By recognizing the fundamental components of fire and the conditions conducive to its ignition and spread, we can develop effective strategies for fire prevention, suppression, and mitigation. Throughout history, fire has played a central role in human civilization, serving as a source of warmth, light, and energy. However, when uncontrolled, fire can pose significant dangers, threatening lives, property, and the environment. Therefore, it is essential to approach fire with caution and respect, harnessing its power responsibly and taking proactive measures to mitigate its risks. At the core of understanding fire lies the concept of the fire triangle, a fundamental principle that illustrates the three essential components required for fire to exist: heat, fuel, and oxygen. Often depicted as an equilateral triangle, this concept highlights the interdependence of these components in sustaining combustion. Heat serves as the ignition source, initiating the chemical reaction between fuel and oxygen that produces fire. Whether from a spark, flame, or other heat source, sufficient heat energy is necessary to raise the temperature of the fuel to its ignition point, triggering combustion. Fuel represents the combustible material that undergoes oxidation during the combustion process, releasing energy in the form of heat and light. Common examples of fuel include wood, paper, plastics, gases, and liquids, each with its own unique properties and combustion characteristics. Oxygen acts as the oxidizing agent, facilitating the chemical reaction between the fuel and heat source. It is essential for sustaining combustion by providing the necessary element for oxidation to occur. Without an adequate supply of oxygen, the combustion process cannot proceed and the fire will be extinguished. Fires exhibit a multitude of characteristics, each contributing to their dynamic and unpredictable nature. Understanding these characteristics is essential for comprehending fire behavior and assessing the associated risks effectively. Fire generates intense heat energy as a byproduct of combustion, capable of reaching temperatures exceeding thousands of degrees Celsius. This heat radiates from the fire, heating surrounding materials and igniting additional fuel sources, contributing to the fire's propagation. Flames are visible manifestations of the combustion process, characterized by their luminous appearance and varying colors, depending on the materials being burned. Flames result from the exothermic reaction of fuel with oxygen, emitting heat and light as they consume available fuel. Smoke is a complex mixture of airborne particles, gases, and vapors generated during the incomplete combustion of organic materials. It consists of carbon dioxide, water vapor, carbon monoxide, and other toxic substances, posing significant health hazards to occupants and firefighters. Fires have the potential to spread rapidly under the right conditions, fueled by the availability of combustible materials, adequate oxygen supply, and favorable environmental factors. Rapid fire spread increases the intensity of the blaze and presents challenges for evacuation and suppression. By recognizing these characteristics, firefighters and safety professionals can assess fire conditions, anticipate potential hazards, and develop effective strategies for fire prevention, suppression, and evacuation. Fires can be ignited by various factors, each representing a potential source of ignition that, under the right conditions, can lead to combustion. Understanding these common causes of fire is essential for identifying potential hazards and implementing preventive measures to reduce the risk of fire incidents. Malfunctioning electrical systems, overloaded circuits, frayed wires, and faulty appliances are common culprits behind electrical fires. Poor wiring practices and the use of damaged or outdated electrical equipment can increase the likelihood of electrical faults and subsequent fires. Unattended cooking, overheated cooking oil, and flammable cooking materials are frequent contributors to kitchen fires. Improper cooking techniques, distractions, and misuse of cooking appliances can escalate minor incidents into full-blown fires, posing risks to occupants and property. Careless disposal of cigarettes, matches, and smoking materials can spark fires in homes, workplaces, and public areas. Smoldering cigarette butts, improperly extinguished smoking materials, and smoking in prohibited areas increase the risk of fire ignition and potential property damage. Furnaces, space heaters, and other heating appliances can malfunction due to mechanical failures, improper maintenance, or operator error. Overheating, electrical faults, and combustible materials placed too close to heating sources can trigger fires, particularly during colder months. Deliberate acts of arson, involving the intentional ignition of fires for malicious purposes, pose significant risks to lives and property. Arson incidents can occur in residential, commercial, or industrial settings, often resulting in extensive damage and endangering occupants. Understanding how fire behaves is crucial for predicting its movements, assessing risks, and implementing effective fire safety measures. Fires exhibit dynamic behavior influenced by various factors, including fuel type, environmental conditions, and available oxygen. Different types of fuel burn at varying rates and produce distinct fire behaviors. For example, combustible liquids may ignite quickly and burn intensely, while solid materials like wood may smolder and produce long-lasting fires. Understanding the characteristics of different fuels is essential for assessing fire behavior and determining appropriate response strategies. Environmental factors such as temperature, humidity, wind speed, and terrain can significantly influence fire behavior. High temperatures and low humidity levels can increase the flammability of vegetation and accelerate fire spread, while strong winds can cause fires to spread more rapidly and unpredictably. Terrain features, such as slopes and valleys, can affect fire behavior by altering airflow and fuel availability. Oxygen is a vital component of combustion, supporting the chemical reaction that sustains fire. Adequate oxygen supply is essential for maintaining combustion and sustaining fire growth. Insufficient oxygen levels can inhibit combustion and lead to fire extinguishment, while increased oxygen availability can intensify fire behavior and accelerate fire spread. Fires progress through distinct stages, each characterized by unique behaviors and challenges for firefighters and occupants. Understanding these stages is essential for effectively managing fire incidents and implementing appropriate response strategies. The ignition stage marks the beginning of a fire, triggered by the introduction of a heat source to a combustible fuel source. Ignition can occur through various means, including open flames, electrical sparks, or frictional heat. During this stage, the fire is in its initial phase, and its size and intensity are relatively small. As the fire continues to receive heat energy and fuel, it enters the growth stage, characterized by rapid fire spread and increasing intensity. Flames become more pronounced, and the fire generates significant heat and smoke. During this stage, the fire may transition from a localized incident to a more widespread emergency, posing greater risks to occupants and property. The fully developed stage represents the peak of the fire's intensity and heat release. Flames reach their maximum height and temperature, and the fire consumes available fuel rapidly. Smoke production is extensive, reducing visibility and hindering evacuation efforts. Firefighters may encounter significant challenges in containing the fire and protecting surrounding structures. As the available fuel is consumed and the heat source diminishes, the fire enters the decay stage. Flame size and intensity decrease, and the fire begins to smolder and produce less heat and smoke. While the risk of immediate danger may diminish during this stage, hot spots and residual heat can pose hazards to firefighters and property, requiring careful monitoring and extinguishment. Understanding how fires spread is essential for assessing their potential impact and implementing effective fire safety measures. Fires can spread through various mechanisms, influenced by factors such as fuel availability, ventilation, and environmental conditions. Direct flame contact occurs when flames come into direct contact with combustible materials, causing them to ignite and propagate the fire. This form of fire spread is common in open-air environments or within enclosed spaces where combustible materials are present. Radiant heat transfer occurs when heat energy radiated by flames heats nearby combustible materials, causing them to ignite and contribute to fire spread. This mechanism is particularly significant in wildfires, where radiant heat can ignite vegetation and structures at a distance from the main fire front. Ember cast occurs when burning embers or firebrands are carried by wind currents and deposited onto combustible materials, causing spot fires to ignite. This form of fire spread is prevalent in wildfire scenarios, where embers can travel long distances and ignite new fires ahead of the main fire. Firebrands are burning embers or debris that are lofted into the air by fire activity and carried by wind currents. When firebrands land on combustible materials, they can ignite spot fires, leading to the rapid spread of fire in multiple directions. Surface fire spread occurs when flames move across the surface of combustible materials, consuming available fuel and generating heat and smoke. This form of fire spread is common in wildfires, where flames travel along the ground, through grass, shrubs, and other vegetation. In addition to the immediate dangers posed by flames and heat, fires also present significant health risks due to the inhalation of smoke, toxic gases, and combustion byproducts. Smoke inhalation, in particular, can cause respiratory problems, asphyxiation, and long-term health issues, making it essential for occupants and responders to understand and mitigate these risks. Smoke is a complex mixture of airborne particles, gases, and vapors produced during the incomplete combustion of organic materials. Inhaling smoke can irritate the respiratory tract, leading to coughing, wheezing, and difficulty breathing. Prolonged exposure to smoke can cause lung damage, exacerbate existing respiratory conditions, and increase the risk of respiratory infections. Fires produce a variety of toxic gases, including carbon monoxide, CO, hydrogen cyanide, HCN, and hydrogen chloride, HCl, among others. These gases can impair the body's ability to transport oxygen, leading to carbon monoxide poisoning, asphyxiation, and other adverse health effects. Exposure to high concentrations of toxic gases can result in loss of consciousness, respiratory failure, and death. Combustion of synthetic materials such as plastics, foams, and fabrics can produce harmful byproducts, including dioxins, furans, and volatile organic compounds, VOCs. These chemicals can linger in the air and on surfaces long after the fire has been extinguished, posing ongoing health risks to occupants and responders. Smoke contains microscopic particles, known as particulate matter, PM, which can penetrate deep into the lungs and enter the bloodstream. Did you know? The concept of the fire triangle, which explains the three essential elements necessary for a fire, heat, fuel, and oxygen, was first proposed by a chemist named Justus von Liebig in the 19th century. This fundamental principle remains a cornerstone of fire safety awareness and education today. We hope that you enjoyed and learned something new from the first element of our basic fire awareness course. As we conclude this element on understanding fire and its risks, it is evident that fire is a complex and dynamic phenomenon with far-reaching implications for lives, property, and the environment. By gaining a deeper understanding of fire's nature, characteristics, and associated risks, we empower ourselves to mitigate its dangers effectively and ensure the safety of ourselves and others. You will now be given a set of 5 questions, which must be answered correctly in order to progress to the next section of the course.